Thanks for watching, and in honor of Valentine's Day, let's calculate the area on the heart. And no, not a cardioid, an actual heart, which looks something like that. Whoosh, whoosh, woo, woo. Wow, so accurate. And before we do this, notice there is a nice symmetry here, because x is an odd function of t. On the other hand, y is a bunch of cosines. So it's even. And what is this saying is that the graph is symmetric about the y-axis. And really what this is saying is that in order to calculate the total area, we just need to calculate 2 times the right area. So area is 2 times right, because as they say, 2 rights make a wrong. And in order to do this, we now need to use a formula for areas under parametric curves, which here tells you that it's 2 times the integral of x dy. Well, so it's easier to do it this way. But you just have to be a little bit careful, because you need to figure out which endpoints or which t the endpoints correspond to. First of all, notice this happens when x is 0. So if t is multiples of pi m, which gives you the suspects 0 and pi. But notice for 0, y is 3 minus 1, 2, minus some smaller numbers. So at 0, y is positive, meaning that 0 corresponds to that north pole of the heart, and pi corresponds to the south pole. And remember, we're integrating in the positive y direction, which really says that we integrate from pi to 0, not from 0 to pi. So now what this becomes, it's 2 times integral from pi to 0 of x of t, y prime of t dt. Okay, so in this case, what we need to do, we need to calculate x, which is 4 sine cubed, times y prime, but by the Chen-Lu, this is minus 3 sine plus 2 sine of 2t plus 3/2 sine of 3t and plus 4/5 sine of 5t, which then turns into the following. So this expression, which I know looks horrible, but we have the 2 from the right heart. We have minus to put the integral in the right order. And this is y, right? Or sorry, this is x, so 4 sine cubed, and this is y prime, so the Chen-Lu. And then what you can do, of course, is expand everything out to get an even worse integral. And what you get is now the following expression, which makes you question the meaning of life, really, because it is very complicated. But the good news is there is some hidden symmetry in this problem. Because if you look at the second term and the fourth term, it turns out they're symmetric about pi over 2, which can be made evident by using the use of u equals x minus pi over 2 and turning them into odd functions. But remember, odd function, the integral of an odd function from minus pi over 2 to pi over 2 is just 0. So the second and last term, they actually vanish. Okay. So, in other words, we're just left with the first term and the third term, and let's see what happens. As they say, it's left as an exercise to the reader, or even better, it's a challenge for you. And this one, again, try it out on your own, or plug it into Wolfram Alpha, and then you end up getting the following horrible expression. Well, this expression here I present to you, which I know looks horrible, but there's a nice simplification, because remember, sine is 0 at yours truly, at pi m, and therefore sine of 2t disappears, sine of 4t disappears, this disappears. Woo! It's a ghosting party. All right, and then what you end up with is minus 8 times this expression plus this expression. So in the end, this just becomes a following. And then in the end, what you're left with is minus 8 times minus 9 pi over 8, and then minus 3 pi over 16, which now you can simplify to the following expression. So this becomes 9 pi and then plus 3 pi over 2, which becomes 18 pi plus 3 pi over 2, and that's 21 pi over 2. So this is the area of a heart, and with that said, I hope you have a very delicious Valentine's Day. Eat all the chocolates you can. All right, I hope you like this. If you want to see more math, please make sure to subscribe to my channel. Thank you very much.